Hello. In this video, we will introduce numeric types and operations. We already used the operators plus, minus, times, and divide. And we'll look at all the data types now. We already used the int and double. There are many other types. So first, let's look at the numeric types in C++. You can have short, unsigned short, int, unsigned, int, long, unsigned long, 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 unsigned long, long, float, double, and long double. Alternatively, they have different names. Short, it's same as short int. Unsigned short is same as unsigned short int. Now, what's the difference between short and unsigned short? It's short, you can have negative values. Unsigned short, there are no negative values. So see, the range is 2 bytes for short. So you can represent the values between this negative 215 to 215 minus 1 for short. And for unsigned is from 0 to 216 minus 1. Int is 4 bytes. Unsigned is all non-negative integers, 4 bytes. And long in most systems also are the same as int. So this is the 32 bits, it's 4 bytes. Long is double size of long. It's 64 bits, it's 8 bytes. Float is 32-bit IEEE convention, IEEE 754 convention. So this is the value you see here. It is between this range. Now, what's double? Double is just more precision, representing and more digits. Look how many digits you can have. This is a lot of more digits, and the more slightly larger range you can represent the negative and the positive side. Long double is 80 bits. So this is the 80 bits. It's more precision, and then the double, and then float. Now, why I put this long here, the size the same as int, it is in C++, it really depends on the platform you're using. On some platform, long is longer and then int, and long is even longer than long, so it can be more than 32 bits and for long. So that's the nature of C++. It depends on the platform. So majority of the C++ standards are the same, but when it's implemented on the different platform, there are some variations. When we write our program, mostly we are going to use int for integers and double for floating point numbers, representing real numbers. And that is just to make things easy. So we use double and use int. Now, please note that, and these are alternative names called synonymy. So short int. So you can use either of this. In the future, you'll see you can actually define your own alternative names. you can use this program to test out and what is the size and what is the maximum, minimum. Here's the int. So this is the constants here. It defined in this the C limit and C float. You have all the constants. You can have this, the constants to define. So this is the long, what's the minimum value for long? So here's the minimum value for long on this computer here on the server. And the maximum value, see this is all the same here for the int and long. Now you can also look at the size. So this is the size of, so what's the size of here for int is 4 bytes. And what is the size of for the long? Size of for long using this operator, size of this function, you can see this is 4 bytes. For the double is 8 bytes. Now you can test, so what is the size for long double? So I'm going to size of long double. So let's see if we can write this long double here. See if that's going to work. All right, it works. The long double is 8 bytes. Look, this is actually 8 bytes on this on the server. And I have the Windows server running for this. That's only 8 bytes. So the same as double. Long double is same as double. All right, so next we're going to look at the numerical literals. So this, when you write a 34, that's called a literal. A literal is a constant value that appears directly in a program. And this is a real value, 0.305. So this is assigned to double. Now you can get a number as decimal, integer, and binary integer, octal integer, hexadecimal integer, and using this, OX is representing a hexadecimal integer. So this O here is for the octal. It's the radix is 8. Now this is very important. I really want you to look at this appendix D. If you're not familiar with number systems, see what's the binary number, what's the octal number, what's the hexadecimal number. So the hexadecimal number is very important for the writing computer programs. It is an abbreviation of binary numbers. So all the numbers internally are represented in binary format. So that's what we are going to use a lot. So please become familiar with number systems. Floating point literals can be written in scientific notation. So we are familiar with this form. You write the floating point numbers is A times 10^b. So what is this here? You can see this. This number here, this number right here, you can write it as 1.23456 times 2 times 2. So you move the floating point 2 positions to the left, and here is 2. And here you move this point 2 positions to the right, so this is -2. When you write a program, how do you write this? 10^2, 10^-2. So use E for this, E2. So the same as E plus 2. And this is E minus 2, the same as, this is the E minus 2. You can use uppercase or lowercase E. Now, when we look at this point, it can goes to left and right. So that is the word floating comes from. So this is a floating point. So why it's called a floating point? Because these numbers are stored in scientific notation internally. So this is exponent part and the number part. So the exponent, the point, decimal point floats. So this is called floating point numbers. To improve readability, C++ allows you to use single quotes as digits separated between two digits. So this is here. You're going to separate this. You can separate this using this. However, you cannot put this separate at the end or in the front. You can only put the separate in the middle. Now let's look at the numeric operators. So these are the operators we're familiar with: addition, subtraction, multiplication, and division. So let's pay attention to this first division. Division is this. If you have two integers, the result is integer, the fractional part is truncated. So be careful when you do 5 divided by 2, it is 2, it's not 2.5. But 5.0 divided by 2, it is 2.5. So that's because one of the operands is a floating point number. Modulus, it is the remainder. So this is 20 remainder 3. You get the result, it's a remainder that is 2, the remainder. So for the remainder is this, you have this number here is 20 remainder 13 is 7. Why is 13 is 7? So you divide 20 divided by 13, and you have this quotient is 1, and here is the remainder. So this is the remainder, 7. Well, let's look at this example here. We're going to display time. So we're going to enter the time in seconds. Here is integer is entered. We're going to enter this integer. So we get the minutes from the seconds. And then what about the remaining seconds? So that's what we're going to do. Remaining seconds is seconds remainder 60. And the minutes is seconds divided by 60, integer division. So this is what we get. Look, so here, we're going to have, look, the time is 500 seconds. So how many minutes there? It's 8 minutes. So that's seconds divided by 60, 500 seconds. And what is the remaining seconds? Remaining seconds is seconds, remainder 60. How do you write the exponent operation? So here is this, using the power AB. This can be used to compute A is B. So power 2.3, 2.03 is 2 is 3, that's 8. So here, and that's 8. And this power 4.0, and this, the exponent is 0.5, it's a square root of 4. So that is, the result is 2.0. So that is for the power. That is all for this section. We introduced numeric types and operations. See you on the next video.